live now. Okay.
Yeah, I'm prepared. I
Okay. Is it clear there?
Ah, yeah.
Okay. So welcome once again to the Epimas channel, Epimas series on the Fema Freak Maths channel on YouTube. And today we'll be doing percentages. We'll be doing percentages. And it's just a continuation of whatever thing that you have been doing. So about 2 weeks ago, we started something in fractions, and last week we looked at probabilities, and then today we are looking at percentages. So you quite remember last week I mentioned that when it comes to probability, the range is between 0 and 1. So probability is between 0 and 1. Where you have the probability of 0 means that that thing is never going to happen. It's impossible. And then when you have a probability of 1, that means that that thing is certainly true. So it means that definitely it's going to happen. So in between never going to happen and surely it will happen are the uncertainties that we call probabilities. So in percentages too, we are going to find something very similar to that. And this time it's going to give us between 0 and then 100. Usually, when people write exams, especially in BECE, one typical example I know is when it comes to the science paper. Your science paper is going to be in about 3 sessions. You have objectives, you have theory, and then you have practicals. Usually, they mark this whole thing out of 130. So you have 130 marks, but you know that your grading system doesn't go beyond 100. So everything out of 130 needs to be brought down again to the scale of 100. In doing that is what we call the percentage. So we are striking the percentage out of whatever that you have. So when we talk about percentages, it's basically having a weight which is out of 100. So you have something and then you want to measure that, okay, if I bring this whole thing that I have on a scale of 100, what am I going to get? And that is basically what you call percentages. So usually there's going to be a certain fraction. That is why you need to know the concept of fractions before percentages. So when you are calculating percentages, it's definitely going to be a certain fraction multiplied by 100. So if I want to find the percentage of something, it's always going to be a certain A over B, which is the fraction part, and then I multiply that by this unit, which is 100%, and then we get what we are looking for. So this is the idea that we are going to use throughout whatever we are doing today. So we are going to look at some questions and then see how it will be like. So example, let's say you wrote a class test, not an exam, and then let me put it in this full statement. So let's say Amma scored 4 out of 10 questions in a test correctly. So the question is, what percentage of the test did Amma get right? Okay. So we all know that usually when you write a class test or a score, a normal exercise in class, the score your teacher will give you will not be the percentage one, except maybe in exams or something. But it doesn't mean that it can't be converted to percentages or you can't still calculate the percentages out of it. So a typical example is this one. So Amma wrote a certain test in class. She had 4 out of 10. So here, this 4 out of 5 we see here is the fraction we are talking about. So the whole questions for the exams was 10 different ones, and then Amma managed to get 4 out of these questions right. So then if I am to find the percentages, then that's going to give me 4 out of the 10 questions. And then from whatever I put here, it says to multiply that by 100%. This 100% is a constant. It serves like the unit that you are going to use in the calculation. When you get a question like this simply takes you back to multiplication of fractions, because this is a fraction and this 100% I can easily divide here by 1, and then I get another fraction here. So this is basically multiplication of fractions. And from what we studied under multiplication of fractions, we are supposed to first check if the numerators can cancel the denominators or reduce them in any way, or if there are numbers which can equally do that, we do that. And then we multiply finally the top one by the top one, and then the down one also by the down one. So here we can clearly see that we can use 2 to divide these guys. So 2 divides 4 2 times, and 2 divides 10 5 times. That is fine. Now 5 and 100, one is down, the other is up. So we can as well divide them. So I know 5 can divide 100 20 times. And you can have your long division done and you see that that is correct. So in that case, I am simply left with 2 here multiplied by 20%, and that should be equal to 40%. So it means that Amma had 40% of the test right. Amma had 40% of the test right. And usually you will see these things in your objective paper. So you just fish out for the fraction part, and then when you have the fraction part, we can look at it the other way around. Okay. So when you have this idea, we can do some change of subjects to find out which of them she had correct, if the percentage is given, or the total number of questions which were there, if I still have my percentage given. So we will dive into the BECE past questions and then take some examples from there and then solve. So let's take our first example. So this from 2015 says that in a test consisting of 90 questions, Amma answered. It looks like today we are using Amma a lot. Hmm. So if you are an Amma and then you write a BC, just because you see a lot of your names there, you should be ready to get most of the questions right. Hmm.